Hi, astronomer Steve Lord here with tips for planning your 2017 August total eclipse experience, and also some ideas on how you could do a simulation on your computer of what you might see from where you're planning to observe it. So go to stevelord.net, and as one of the first links, you'll see Eclipse links. And I want to run you through this page because it's got some useful planning tools for you. The first link is to a nice one-page article on how you might experience the eclipse. So this is something from the Westways magazine describing what it would be like to experience the eclipse. I recommend it as well written, and its links. And now to start planning, this link here by Xavier Jubier is excellent in terms of getting started for planning. It's a Google Earth utility where if you zoom out, and I don't want this label right yet. If you zoom out, we just need one Earth, you see the extent of the eclipse. And you'll notice several things. The eclipse path is narrow going through the United States. It starts and ends in the ocean. You'll notice that the path gets thicker from left to the center and then thinner again to the right. That means the shadow of the moon gets smaller. And you see that the band of totality between the red lines is very narrow. So it's only about 60 miles of the path of totality. And what's great about this is you can zoom in, because it's Google Earth, and you can find cities that you might want to go to, locations, and you can click on a particular location, and you will be given a lot of useful information all at once. What time the eclipse starts is probably one of the important things for you, and this is universal time. In states with daylight savings time, you have to pay attention to that. For example, the West Coast is normally 8 hours earlier than UT, but during the summer daylight savings time, it's 7 hours earlier. So this eclipse will start in the Pacific time zone around, or at this location in the Pacific time zone around 10:19. It varies with the location, and totality will last, it tells you up here, a little more than 2 minutes, and the eclipse shadow, the umbra, will be traveling close to 3,000 miles per hour. So it's going to get across the United States in an hour, and therefore it doesn't vary when totality starts that much within a time zone, a few minutes. And it tells you other important information. It tells you the longitude and latitude of the site. Now this is in decimal form, so west longitude is a negative number, and north longitude is a positive number, etc. And it tells you some angles between the sun and the moon, which aren't necessarily relevant to you unless you're really doing some precision astronomy. It tells you the moon size in the sky is slightly larger than the sun, which means it's a total eclipse, 2%, 3% larger. This isn't always the case. You can have annular eclipses where you have a ring of fire around the moon, but the total eclipse is much more spectacular. And it tells you the beginning and the ending of partial phases, and it actually shows you during these phases what the shadow of the moon looks like. So you can see it's an oval striking the Earth and moving along. Okay, in a few minutes it does all that. And you can zoom in deep and see various percents of totality at different locations or various if you get off the eclipse path, and you can also see the duration diminish as you go from the center of the path because the shadow is not that thick where you are. Okay, so you probably want to pick a place in the United States and write down a longitude and latitude and think about it. So the next site I'd like to show you is a planning site where you look at the weather, and this is a very good site by Anderson and West. I'll go to a specific example of it in Oregon where we just were. Remember, we wrote down the coordinates, and I have it on the screen more easily. And you see the region we were just looking at showing the eclipse path, and you can see the various towns that the eclipse walks through, as well as the terrain, mountainous or plateau or seashore, etc. But what's really great about this site is the weather. You see what the probability of rain is, how rainy the region is in millimeters per year, and you see this for different parts of this. So the green is where the mountains are, and they release the rain from the clouds, and you can see it's rainier on the windward side of the mountains than the leeward side. And this is August precipitation, not yearly. I said that wrong. But even better is this map, which I really like, this chart, which is the cloud cover in August, on August 21, averaged over many years, and the probability of cloud cover, in other words, how many days you have each of these situations where there's clouds 80% of the day or 20% of the time on the day 21st August. And this is the east coast of, the east half of the country, and this is the west half of the country. And you notice, of course, it's cloudier going toward the more or the less dry east coast. And likewise, you have to consider that cloud cover is not the only consideration. The humidity in the atmosphere is important because the temperature can drop quite a bit during the partial phases of the eclipse and cool the atmosphere, and so you can get more condensation, especially if you have water vapor in the air. So it might be only partially cloudy here before the eclipse, but during the partial phases it could get completely overcast. I've had that experience. And we were just looking at the Columbia Plateau in Oregon a second ago, and there are other tables telling you what types of clouds there are in different regions of this state, but this website has all the states that the eclipse passes through. So you can see here the weather maps for the other regions. And going through this quickly, you can see what the experience of totality might be like, and there's a lot of tips on glasses and covers for your binoculars and cameras where you can buy or get free glasses for the eclipse. There's 3 or 4 phenomena that occur before and after the eclipse that are exciting. The Bailey's beads are just before totality, when the lunar valleys have streaming of the sunlight through them because they're a little deeper than the mountains, say, and we don't need that. And you see these beads of light as the last rays of sun go through the lunar valleys. Likewise, you can look at the pinhole cameras that are made effectively by leaves in the partial phases. So here's a view of that, a tree blowing in the wind and projecting all these images of the almost completely obscured sun onto a garage door. And then there's a very interesting phenomena I really recommend called shadow bands, where there's streaming of the atmosphere actually the beam of the sun goes through the atmosphere, and you can see in say on a piece of paper that the sun is being projected on. As you get closer towards totality, if you look at this image very carefully, you can see that there's something funny going on with the light as it streams through the atmosphere. Actually, as the Earth spins under this beam of light, not a big disk of light now, but a sliver of light from the sun. It feels like the light from the sun is electric at this point as you get closer and closer to totality. Kids sometimes chase these bands of light. It's been known to happen. So finally, those are the phenomena that you might find. There's if you have protection from the sun, you will be able to see sunspots if they're up. We're right off a week solar maximum, but this will be a guide to seeing sunspots if you click on space weather and look at an image of the sun. And today I'm making this video, there just happens to be almost no sunspots, but you might get lucky during the eclipse easily because we're still near the solar max. I wanted to point out there's a great gallery for seeing images from past eclipses, and there's I think one of the best simulations to understand what's going on with the eclipse is this, which shows from NASA the shadow of the moon as the moon projects it onto the Earth. See how narrow it is and how this is now moving at 3,000 miles across the Earth. So about an hour is going by in this simulation. And you see the umbra, which means the complete shadow of the moon, and the penumbra, which means the moon is partially eclipsed in these regions. So almost everyone in the United States can see a partial eclipse. And if we run this back a second, I'll also say that this is the backside of the moon. You have the Moscovianus crater, and you have some other craters named after astronomers, not Aiken Drum. You have the true backside of the moon, which only less than a couple dozen people have ever seen. And one thing you might notice is that the moon is actually going around counterclockwise as seen from above, but the Earth is spinning under the moon faster. So both of these things are happening. So the angle projected by the moon shadow moves to the east, even though both the moon and the Earth are, did I say the sun? Both the moon and the Earth are spinning to the east. The Earth is spinning faster, and here it goes out into space. The shadow's gone. Then finally, I want to introduce you to Stellarium. And Stellarium here's the homepage of Stellarium, which allows you to do a free download of this software. It's great software. You don't need to be doing an eclipse to be interested in this software. It has great simulations of the night sky. And likewise, if you're going to use it, I also recommend clicking on this link I have for the shortcuts page, because you really want to control it by the keyboard. Now I'm going to do a short demo with Stellarium and show how to set up for the eclipse. So we'll take this, and I have future eclipses there too. Okay. So we bring up Stellarium, and it's got the current location. And the first thing I'd like to do with Stellarium is put it in its own window. So I bring the cursor down here. This will allow me to do it, this particular icon. The second thing to do with Stellarium is to set the correct location. And this side panel is a bit sensitive. If you click on it, I got the location window, and you can type in the longitude and latitude we looked at before in either coordinate style. I happen to have saved it as a position, so there we go. So we've got the location set. So let's get the time right. And the eclipse happens on the 8th before sunrise. we're going to set before sunrise. We see what's happening here. It happens after sunrise on the 24th, 8:24, 8:21. Sorry, it happens after sunrise in 8:21. I think we can go another hour here, and go to the east where the sun rises. We notice that Orion is up. Now we use the L key in advanced time. Remember, J, K, and L are very useful. So there's a satellite going by, and I'll slow down a little bit. We're at 5 a.m. Let's get to about 8 a.m. There's the sun and the moon together. The black dot is the position of the moon. Okay, let me pause and get a little more sky here and zoom in a bit. This will be iterative. So I'm using the L key again and advancing. We're going through 9 o'clock a.m. and we're up to 9:30, and we're in the regime of first contact between the two disks. I'm going to slow it down again, sort of like watching a space shot. Okay, so we're very close. This is where you get all those weird phenomena that I was talking about before. It's interesting phenomena. There's Regulus at the foot of Leo, and this is 40 degrees up. If I were to click on the sun or the moon here, I would get all the details, but I don't need them. It's watching it is more fun. And so let's watch totality occur. Now this is where you get the Bailey's beads. They've actually simulated them for you. As the light streams through the lunar valley, I think that might be a planet. Let's see. No, it's Leo. It's a star in Leo. Okay. And now you're beginning to see the corona, the several million. We've let time actually show us the corona. Now we're in totality. You might see prominences, which are arcs of plasma connecting sunspots. The arcs might be several times the Earth, being orange. You see the corona, and the streaming is caused by the solar wind passing through holes in the corona. And this will last for 2 minutes. And the birds will be very nervous and stop calling, and the dogs will bark, and traffic will stop, and it's an exciting moment to see the two most massive objects we can look at with our eyes, one hiding the other, and the coincidence of the angular sizes being almost exactly half a degree each. Their distances away is proportional to their physical size. And after 2 minutes, you will see a diamond ring of light as the first sunlight streams through a lunar valley, or the last that during totality, when totality happens, and then you have the partial phases again. Okay.